I'll be getting started soon. Just record or write down any kind of questions you have as you go along, Ethan, and we'll see how many other people show up. I'm just going to mute for a second and stop recording. So I'm going to talk about dynamic memory, and we're going to talk about strings, but that's C strings. There is a difference. I like using that different term simply because everyone will just keep talking about strings, but a character string, as the traditional old school way of doing things in C and C, is slightly different than the string object class. So if you're dealing with strings in Java, they will look different than what you're used to, what you'll see in C++ or in C. C++ also has things, string objects, just like in Java. They will look very similar. But there's a difference between what you would see in Java, what you would see in, like, say, Python, and what you see in C. So let's do that as fast as I can. So let me just make a brand new class or a brand new file. And I don't want a class, I just want this. And we're going to call it C arrays. I'm also going to have to move this around because it ended up being plopped into my A7 directory somehow. Okay, so here's A7, here's C arrays. And I'm going to have my int main, my usual approach. A dynamic array. So let's make a static array just so we can see what we're talking about. Here is me making a static array. This will make a chunk of memory 20 characters long in total. So that is 20 times 1 byte. Each character is 1 byte. If it was an array of integers, it would be 20 times 4 bytes long. This is 20 times 1 bytes long because a character is 1 byte each. Okay, it's just a contiguous chunk of memory, and I can jump to the different places. Okay, how about this then? Dynamic text, and I'm going to also make that, I'm going to set that up in a second. This is going to be what is our dynamic array. A dynamic array just means we don't know how big this thing is. When I run the program, I could ask the user, hey, how big do you want this array to be? Let's actually do that. So int array size, and I'm going to say just so you can see it in action. How big do you want the array? And let's make it an unsigned int so it's all right. I'm going to need to include this, so it's not automatically giving it to me. Here we go. Standard IO hopefully will do it. There we go. Great. Now I'm going to use my scanf. I'm going to take in and I will need to make this put an and in front of it. The reason I need to put an and in front of it is that this is actually technically going to be a pointer. We will get to pointers later, not until after the exam. So this will just get me my array size. I put in 42, I get an array of size 42. Fine. So let me make a new dynamic array of this for this. So a dynamic text is equal to, and then I'm going to make my array now. But notice I can't change this from a 20 to a 40 to a 72. Like I can't make it whatever I want it to be. I set it and forget it. I say I'm going to make an array of size 20. The compiler can allocate that memory or get that memory for me before I even start this whole program up. But if I have dynamic memory, I got to ask the operating system, hey, can I have this much memory? And you don't know if it's going to give you that memory or not. But it also means you can adjust the amount of memory I need on the fly. So if I have a text file that I'm reading in and I don't know how many different courses I have, or I don't know how many people I'm going to be reading in, how many different lines of the text file I have, I actually need a dynamic memory. Or I need to make something huge, some huge static memory, and hope to gosh I don't use it all. Those are my two options, really, right? If I can't adjust it on the fly, I need to overshoot things. And if I can, so if you don't know if you're going to pass the exam, you need to make sure, like, if you don't know what you need to pass or fail the exam, you just need to aim for 100%, right? You don't know what you need, so you have to overshoot. If you know what you need, you can be a bit more cautious about how much you shoot for things. So dynamic arrays are really useful for, especially for really large data sets. Okay, here is what it has a weird particular pattern to it. It's going to be a char star, as in this is a pointer. We're going to look at pointers very soon. It is a pointer. Yep.
Sorry,
Okay.
you haven't been sharing your screen.
Thank you. I appreciate when people finally tell me these things. I've forgotten that so many times. Thank you.
Yep, no
Let
worries.
me let me where's my screen sharing? I'm going to full size this thing. Pause recording, breakout. Why won't it show me my screen sharing? All right, let's full size screen share. I very much appreciate that. Okay, here we go. Much better, huh? Yes, there you go. So it was a great explanation if it wasn't for the fact that you couldn't see a damn thing I was talking about. Here is a static array. I can't adjust that on the fly. It will always be 20 bytes long. Is the size of a character times 20. Each character is 1 byte, so 20 bytes long. I can't adjust that. A dynamic array is, I'll figure it out later. And so here I'm going to ask, I'm going to start off at size 0. I could have it 0. I'm going to say, how big do I want the array to be? And then I can get that value from the user, and I can make it whatever size I want. I can't predetermine that. The user is deciding how big this thing is. So I might also want to include some asserts just to make sure. This is where an assert actually would come in handy. Actually, let's not do an assert. Let's do if array size is less than 1 or array size is greater than 400. Just I'm forcing it to some kind of safe value. So if you give me something stupid like 4 billion, I'm just gonna no. I'm making it size 20. I don't want to make 4 billion an array size 4 billion. That's going to be nuts. So, okay. A dynamic array has a weird particular thing. First of all, it has it makes sense. Malloc stands for memory allocation. It does not make sense in the fact that it's old school. You had to know how things were working under the hood. When you get to C++, you get to call new, and it seems to, at least for me, it makes sense. I'm making a new array. It's going to be called new. How big is it? It's this many things. For malloc, it says, how many bytes do you want? And then afterwards, you're going to pretend it's this many characters wide. So if I say I want an array of integers, I need to figure out how many bytes that is, and then I chop it up myself. If I say it's an array of characters, I make it however big that is, and I chop it up myself. So I'm going to make a malloc, and it's going to be the size of how big is a character. It ends up being 1 byte, but you don't want to put 1 because just in case, just get in the habit. Just call size of each and every time. Multiply by how many characters I want. So I'm going to say array size. That's how many characters I'm going to have. This will ask for whatever that number is. So if the person puts in 20, then it's going to be 20 times the size of a character, 1 byte. And I'm going to see what the heck is going on with my malloc here. Malloc is not defined. That's a load of hooey. Malloc is certainly defined. So what the heck is going on here? That should not have done it. Well, I guess standard IO. It's for memory allocation. I can't believe I would need to actually include I shouldn't have to do that. That's really surprising here, but it's just going to allocate a chunk of memory and give it to me. It's going to give me where that thing starts. It will act, look, behave, smell like the astatic text array It's going to be identical to it, almost in every way, shape, and form. And that's sort of the point, right? The static array looks like an array. It's just a big chunk of memory that I walk down. This thing is a big chunk of memory that I walk down. There's no difference between, really, there's not a real difference between a static array and a dynamic array. There are differences, but how you treat it effectively ends up being the same. And this is actually why I have this a underscore thing that I keep putting in there. You'll be sick of that soon enough if you're not already. The reason I have that there is because I want to know it's an array. Otherwise, I just think it's a pointer to something. It's just pointing to something. What is it? I don't know what it's pointing to. If it's an array, I want to say, by the way, there's an array there, because otherwise I can't tell. So this is going to give me an array of that size, that many characters. And then afterwards, by the way, before I forget, I want to make sure I free up my A dynamic text array when I'm done with it. Okay. Let's do this. Let me think here. Oh, that should be fine. Let's use our string functions that we already have, because we're talking about C strings. A C string, all it is a character array. I store a bunch of text or characters in an array. But if I do it right, I can do something. There's something interesting I can do that I cannot do with an integer array. What would be a number that I could use to say I'm at the end of my integer array? Nothing really. The numbers are contiguous and they go in both directions, and there's no safe number for me to use that says, hey, by the way, I'm at the end of my array of integers. For all I know, I needed that number. Character arrays have a special character at the end saying, hey, I'm at the end. That's at /0 character. And that allows me to not have to pass around, by the way, my character array is this long. The array is this length. I just go until I find that 0 at the end. That's all I'm doing. And so I have some built-in functions that I can use that I couldn't use otherwise. So what I'm going to do is I'm just going to, I can call malloc on both of these cases. I'm just going to set some kind of text in each of these strings. So let's do, what could I do here? I could use a scanf. Scanf would work, I think. So printf, type in the first message. Shouldn't be a mess. Should it be a message? I could use getS, I guess. Yeah, sure. Let's put in the first message. Okay, and notice this looks very much like what we did on the assignment with fgets. The F stands for file. That's the only difference. This one, instead of getting it from a file, I'm going to be getting it from the user. That's it. Okay, I'm going to get a bunch of information for the user, and I'm going to get, and it's going to be put in here into this array. I could also, at the end of the day, it will pass in a pointer to this, and if something goes wrong, it'll return null. We'll look at null soon enough. But I want to put in this. Okay, and what happens? Do I have something that's going to let me be safe here? Let me make sure I can't put anything that's going to blow up in my face. Nope, fgets. I thought I was supposed to be able to, let's compile it and see what happens. Oh, there we go. Now there's something going weird. It's char star. Dynamic text is a char star. Unless I did something wrong here. A dynamic text, I'm going to get the character array. Why is this not letting me do this? It should be saying, I would have said, there you go. That's what I was expecting to see. The reason there's an S on there, before I had this function called getS or gets, and it didn't say what the maximum number of characters I could put in there. So if you wrote something that was way longer than the size of your array, It let you do it, and bad stuff happened. Honest to God. So this case, I want to say array size. That's how many characters you can put into this thing. Up here, I should also do the same thing, right? The size of the array is 20. Right? You cannot put in more than 20 characters into this thing, otherwise blow up. Yell at me. Okay. Let's do that. Let's compile it. Let's see how we're doing. Oh, too many arguments passed in the formal string. fscanf underscore s. Oh, fscan. Oh, of course. Look at that one. I want an array, right? So the array size, it's an integer. I don't need that s underscore s if I don't want to. Let's see how we're doing. Okay. Could be 0. This does not hit the specification of get s. Let's have a look. It should be taking in a character array. It might return that could be 0. Oh, our size. Okay. Might be the problem. The character array may not be 0. Let's have a look. Nope. It's this thing. It's the fact it might be a null. Oh, I need to do that actually. If a dynamic text does not equal null, if my malloc actually worked, is what it's yelling at me for. I'm not sure it's still going to give me an error or not. This is just a warning, by the way. If I call malloc here and it doesn't give me anything, if it doesn't allocate that array, this will then be null. If it's null, I can't put anything in it. And so that's what it's yelling at me for. Scanf is a problem here, and this function or variable may be safe. Oh, there's that safe version of things. Hopefully that's going to do it for me. All right. So what do we have here? We have a dynamic array here. We have a static array up here. They will look and behave very, very similarly to the point that I should be able to do the same kind of functions on both of them. And maybe I can do strcm string compare, right? String compare. Str. Let's see what's wrong with that. Come on. I also need to put that in there. And I'm going to put in, let's just put in my things here, a static text, a all right. CMP, that's what it should be, not comp. All right, let's see what the comment was, if there was on the chat. CMP, thank you. Very nice, Luke. Very nice. And sorry about not that again. Great. So that should work, but let's see if there's something missing about this. I might be missing like C string or something like that. It should tell me what the missing function is, or where I get it from. That's just my Visual Studio thing working. Come on. I'm trying to figure out, I'm trying to get the autocomplete here because for the life of me, I think IOStream will work, but that's brute force and ignorance way of doing things. This is multiple.exe written at the database. That is that's just Visual Studio screwing things up for me. Not Visual Studio. I'm using all of this. I'm using a Google Drive to actually hold the code. I'm automatically syncing everything so that you can see my code, and that causes some kind of synchronization issues. Okay, so string compare, it returns something, and we're ignoring that return value. So int, there we go. And we could do something like this. If comp val, let's do it this way. And I want if comp val is greater than 0, print f com and line. We'll see what order these things go in. Why? Because I never remember these things. All right. Else if, me being lazy, if it's less than that, then I am going comes after. All right. Notice I'm not doing anything different between these two functions. I have two completely different ways of making an array, one static, one's dynamic, and I'm calling the same functions in both cases. It makes no difference to me. There's the built-in functions that they would be great to put on your cheat sheet. I know you don't need a cheat sheet because it's, an online exam, but make one. The reason you make a cheat sheet, though, is just to make sure that you know what you don't know, and you know what you can't keep in your head. It's very useful for just preparing you for your exam. Okay, so here is me checking to see, comparing the static text from the dynamic text, and I have 3 different outputs, whether they're the same or not. And then I always make sure I free up my array at the end, because if I don't, this one up here, the static array, that automatically gets given back. The dynamic one says it's mine until I give it back or until my program ends, which means if you don't give it back, you can have a memory leak. If I keep on making a dynamic array, forget I can lose the pointer to it. I keep on pulling in making a dynamic array and just not giving it back, I will eventually run out of memory and my system will crash. If I'm using, let's say, if I'm making a server, it might be 4 weeks from now when your server finally runs out of memory. Good luck trying to figure out what your bug is then, right? 4 weeks later, everything in your code looks wonderful. And then 4 weeks later, the whole thing crashes. And you can't reproduce it other than waiting another 4 weeks to see if it crashes again. That's why you have to worry about this. Get into the habit of freeing up your dynamic memory when you're done with it. Okay, so this string compare, I'm not going to, could be 0. This does not adhere to the specification. Okay. I could put that whole thing in there, or I can just assert. No, I don't want to assert that. I'm going to move all of this stuff in here because otherwise I can't, for freeing the memory as well. If malloc doesn't work, I can't do any of this stuff. So I want to just, I get the message, I call malloc. If it doesn't work, I can't do any of this other stuff. Okay. Let's see it in action and let's hope for the best. Okay. How big do you want the array? Let's say size 30. Type of the first message for type of the second message. Okay. Something weird happened with that one. All right. I don't think I accepted the second message. All right, let's have a look at this. How big you want the array? Getting that. Print message, type in the first message. Okay, I get the message. Okay. Oh, I went to this type in the second message part next. Let me put a breakpoint on that. And let's see what happens. Okay. How big do you want the array? Size 20. Okay, I get to this line. I'm going to go one step further. I'm going to see what it's asking for. Hello. I don't know why it's not listening. happened here. Oh, it's because it's filling this in without anything in there. It's got to be using that first message. Let's have a look at what this thing says. It's taking in, is giving me a 0, get S, underscore S should be taking that. That's something weird going on. I could use fscanf if I wanted to, but let's. $20. All right. And it's just jumping past here and setting it to 0. Why is that? The question is why. Type in the first message. Get S underscore S. Let me just kill that off for a second. Instead of getting it from the user, I'm going to just manually do it. So strcpy, I can do underscore S for the size of this thing. And I'm going to put in my destination is a static text. The size is going to be size 19, not the 0 at the end. And the message is hello world for the time being, because I like using hello world for everything. And let's see what happens with that. 20. All right. So what I should see here is hello world. Great. I'm going to now go on to the next line afterwards. I'm going to type in the second message. The second message, it should be waiting for a user input here, unless it automatically fills it in for me. And let's see. So it's not waiting for the user input. I have an automatic free line in here, is what the issue is. Interesting. Okay. So what could I do here? I could. So getS, I normally use scanf for most of this stuff. GetS, instead of using a file, it will be taking in something from the user. Now, what that message is from the user, it should be taking in a full line of text from the user. It might just be taking in that first enter that I put in when I was using scanf. So essentially, when I did this up here, what's probably happening is it still has that carriage return, that enter that I pressed. As a result, it jumps down to the next. It's automatically instead of just taking that, it still has this extra character, this carriage return, and it's using that as the next input. And so I'm going to burn off that input right here by getting that carriage return. Then I'm going to set hello world. Then I'm going to ask for the second message. So let's have a look at what the heck, if that actually solves the problem. Otherwise, there's something wrong with getS. Okay, how big is my array? 20. Now, I think when I press enter here, what it's doing is it's taking the 20, but then it still has a carriage return sitting around. And so what I would expect to see here is this. Okay, I got the message from the user. And then I set it again afterwards to hello world. Fine. I'm going to press continue and see what happens from there. And if I press enter, that should go into the next value. Here's my dynamic array. Okay, so here is the dynamic text array. It says hello world. The other one says hello world because I did it manually up here. It was the fact I pressed enter. It's just a weird quirk of getS instead of scanf. Okay, now I'm going to see what I've done is I've called string compare between the old hello world message and the dynamic hello world message. Notice they are not identical to one another. One is with a capital H, one is with a lowercase h. Are they actually equivalent? Hopefully you've realized, no, they are not. They are not actually equivalent. That uppercase versus lowercase makes a difference. Uppercase H actually comes before in the ASCII table. It should be that it should be causing a problem. What the heck? My internet's unstable. Let's find out. Hopefully you guys can still hear me. Let me know if you can't. Okay, so string comparison gives me a -1. The static value is so in this case, I'm saying what my original thing says is if it was coming first, the capital H should be coming first then. So I have these reversed. It should be if this thing comes first in the alphabetically, then it should be less than 0. See, one of those things that we figure out that it's going to return a negative value in one case, a positive value in the other case. It's like a balance. It weighs it on one side or the other. And so if static text comes first, you could say it's weighted more heavily, and therefore that's going to give me a negative value. If the other one is weighted more heavily, it'll give me a positive value. And if they're equal, it gives me 0. I have these reversed in here. So what we should see, I'm going to bail on this for a second. I'm going to fix that. Less than, wait, it was less than over here, wasn't it? And this one's greater than. Okay. If I press enter, how big do you want my array? I'm going to make size 20. I've already hello worlds in one of the messages. Hello world comes before hello world. Great, and we're done. And I also made sure I freed up my memory. What I should do is one step afterwards. I should do this. The question is why? That's what we're going to be doing in one of the upcoming assignments, actually. I think it's not this week's, but the week after's assignment. Why do I want to use nulls everywhere? Well, because if I don't know if I freed up that memory yet. I need some way of actually verifying that I freed up the memory or things have not been assigned properly, that it is uninitialized, right? I need some way of making sure, like, have I, when I have a to-do list, right? If I check something off, I know I've done that item. If it's not checked off, I have not done that item. I don't want to have a to-do list where some of the items are checked off, some of them are not. I don't know what the state of things actually is. When I'm done, I check it off. Otherwise, I might do it again. So if it's clean the bathroom and I finish cleaning the bathroom, I want to go to that checklist and check it off, because otherwise I might go a couple weeks later. Yeah. The next day I might look at it and go, oh, I haven't cleaned the bathroom yet. Oh, I better do that now. Right? I don't want to repeat myself. I want to make sure I know where things stand. So when I freed something, I set it to null. Null is essentially just 0. It's a fancy term though, so I know it's a pointer, and the pointer is set to 0. The pointer is not pointing to anything. It's pointing like here up in the air. That's what null is. Just point to nothing. If you're pointing to nothing, then you know that it has not been set up properly or been set up yet. Okay, that was me attempting to do a dynamic array, which involves a malloc and also involves a free. It also is me looking at it also looks at character arrays or strings. And we have some built-in functions involving strings in how to get the length of a string, for example. So strlen, length of a string. strcmp, string compare. strstr is finding a string within a string. strchr, finding a character in a string. We will actually have done that in the assignment. For those of you that actually want that for the assignment, we could do something like str, and let's do this. Instead of hello world, I'm going to do this. There you go. I'm going to find the tab character in hello world. That is actually a legitimate character. It's just 5 spaces, effectively 5 spaces. So I'm going to have a static text. That's what's going to go in. And I'm going to look for this character. And tab pause. Let's say tab PTR. This is essentially just an arrow pointing to where in the text it is. So what it's going to do is it's going to point to right here, this part right here, the location in memory where that /t is. That's what this is going to return. And you were probably wondering, why the hell would I want that? Well, if I know where that is and I know where the start of the string is, I can actually tell how many characters I've moved down. I can do all sorts of crazy things. I could start my string there and just pretend that the characters before it don't exist. We'll look at that in a lot more detail when we get to arrays. Oh, and when we get to pointers. But effectively, what we have here is the following: HELLO/TWORLD. Your character array is just pointing to that H. I have some kind of, it says that's in the location of memory where that H is located. That's all it does. That's all this astatic text is, just pointing to this thing. So let's do that right now. I'm going to change something around here, and I'm going to say, I can't do change astatic text there. Let me think of a better way. What would be the best way of doing this? What I want to do is, well, let's do the printout statement. There you go. Printf. Okay, and I'm going to have tab ptr, and I should have a comma there. So all this is going to do is the tab starting position. Essentially, I'm saying it's a string at the tab starting position, and all it's going to do is it's going to be this. I'm pointing to that T, and everything afterwards is the rest of my string. My original character array is just pointing to that H, and everything after is my string. So let's also put a breakpoint on that thing. And then I want to open the floor to questions, because I'm sure other people have lots of questions. Okay. So string compare, string copy, sorry. I'm moving that hello world over, and I'll look at your question in 2 seconds. Tab pointer points to a location in memory where that tab is. That's the location in memory, 00DEFE91. Position in memory. And if I do the printf statement, let's have a look at what this thing looks like. Tab start position is big old space, because it's a tab, world. Tab, world. That's it. It's just where it's pointing. Okay. Let me continue. And by world. Hello world comes before by world because capital versus lowercase. Okay. Let's see if there's a question in here. Okay. With open, whenever I print the file string, I only get the first line. So you opened it. That's all you've done. You didn't get anything from it. That's a great question to Ben. So I open the file. That just gives me access to the file. It gets me the book from the library, if you will, right? You didn't read anything from the book. You have to go line by line, getting a line. fgets gets you a line. If I call fgets again, I get the next line. It's a stream. It goes from one thing to the next to the next. So every time I call fgets, I will get another line in my file over and over and over again until I get to the end of my line. There's the end of my file. When I get to the end of my file and I say fgets, it'll return a pointer to null. I'm at the end of my string, of the end of my file. And then once I'm there, I stop. So I could keep on asking for fgets. So I could have something like, hopefully this is not going to, while hopefully it's going to be something like this. And I'm going to get something, it's going to go into my buffer, let's say um, buffer size, and I'm going to my file. I'm going to read it from my file. Something like that, right? It's getting something from my file, putting it into my buffer, and every single time I do this, it will put something new into my buffer. I call it a second time, it'll put something in the next line, and then the next line, and then the next line. But when it finally doesn't have anything left in the file, fgets is equal to, so I could say, well, this is not equal to null, would also be the exact same thing. So it just keeps on getting the next line and the next line and the next line. Does that make sense? Let's see how people are doing. Yep, great. All right, that's other questions. I want to see how people are doing, if there's anything else I can unpack for people. Let's put this in here. So when the problem that I have with this part of the course is we're learning about character strings. And so we have these nice little things, but then I have to keep on saying, yeah, never mind, pointers. And then we start looking at memory. And again, I have to say, yeah, never mind pointers. Then we get to actual pointers, which explains why memory works the way it does, how strings work the way they do. But then there's a whole lot of other quirky things involving pointers. Pointers, you can do arithmetic on pointers. I could take the difference between two pointers, it gets me a number, and that tells me how many steps I've taken. You can do all sorts of crazy things. And you can do, in fact, that's all those square parentheses that we have. Let's say, where's a good example of the square parentheses? Well, we have one up here, but it's not the same. These things, right? But if I want to get to a particular element, I normally use a square parentheses. Turns out you don't need to. That's a shortcut. You're actually doing pointer arithmetic to get to that position in there. It gets a little crazy. And so this is just the first step. We'll be looking at this for a while. So it's okay if you're a little bit confused on it. I want to make sure you ask questions and you're coming more to terms with this. The file reading, we just read in line by line from a file. Afterwards, we close it, and we're just pulling off the next part of the stream of different characters. Are too many or too few arguments with strings? Yeah, and that's my problems too. Part of it is you need to know what the actual string. So if I'm looking for scanf underscore s, or better yet, get s, or string compare, there we have these different versions of the same arguments or these same functions. So we have string copy underscore s versus string copy. String copy is the original, and everyone went, whoa, that's dangerous. So string copy underscore s just means you probably have to pass in the size of the array that you're using, because if you don't, you easily go over the end. So we have string copy underscore s just as a safety mechanism. And if you don't know how it's called, Google is your friend. You're allowed to look up how a function is called. You're not allowed to look up the answer to how you do the assignment, but you won't find the answer to the assignment online anywhere. The how do you call string copy, that's perfectly reasonable to look up, but we can also go over any one of those things as well. And most times that's just, I will look at it and I will do something like, let me see if a good example. What would be something I don't ever use? str I use all the time. str cmp, compare, concatenate. String concatenation. So I look at this thing, here's what the template looks like. It is going to take in a character destination. It's going to take in some kind of source. And as an optional thing in here, it should take in the size of my array. That's at least, or there's one overloaded method, meaning that there's two ways you can call it. So it takes in your destination, takes in the source. Concatenation means it putting these two things together, and it's going to say and the thing it's going to return is the size of this thing. It's going to return how many characters should be how many characters I've printed on there. All right, so let's find out how this thing works. Let's move that. So I'm going to do string concatenation. I've went down in here and let's do, okay. So I have a destination and the size of the destination. So a dynamic text. I have my source, a static text. I don't know if I have a something else in here. Well, it's thinking it's a character array. It's a constant character array source. So that should be fine. Oh, it's a constant character array. I'm not allowed to change it, but that's fine. Okay. Is there anything else I need here? And it's going to, this is what it's saying I have here. And let's put in a number here. So, let's see if that works. And this is the kind of thing I'll actually be doing. If I don't know, most of the time my functions have, like, I put in this size, I'll put it in here, let's say, or I'll do a search for strcat string concatenation, or I'll put it back here and see if it goes away, right? If I don't know what it needs, I'll do a Google search and see where the heck it's actually defined. I don't try and keep it all in my head. Therein lies madness. I need to be able to play with it. Once you've seen the pattern enough times, once you've got familiar with it, you just go, yeah, okay, there's something in there. Okay, I'll fix it. Right? If you see someone cook, they're not panicking over every single slice, every time they slice an onion or every time they slice a green pepper. They're just sort of used to it. And if something screws up along the way, they just sort of like, okay, I'll add this instead. Right? You get a bit more, once you get more comfortable with it, you become more able to handle anything that they throw your way. But let's also have a quick look at this. So this is going to return a, I don't know, actually this is just going to return some kind of error message. So let's do this, print f, and I'm going to output the format, spelling. And what do I have here? A dynamic text. Okay. I'm hoping this will actually blow up in my face. So I'm going to run it twice. Once, and you'll see it, hopefully see it in action properly. How big do I want my array? I'm going to make it 40 to begin with. Okay. By world. Okay. And everything works fine. The concatenated string is by world, no space, notice, hello world. It just takes the two strings, squishes them together. That's what string concatenation means. It's appending it on, right? Just squishes them together and puts it in my destination string. So it takes whatever the second string is and squishes it in there. There's lots of these different kinds of functions. And most times you look it up when you need them. Let me run it one more time, but I'm going to make it size 15 by world. Hopefully that's going to blow up in my face. There he goes. Nice. On purpose. What the hell happened? Let's have a look. My error is right here. It triggered a breakpoint. Why did it trigger a breakpoint? And it stopped it right here? Because the size of my array is 15. Hello world plus by world, all of that text together is greater than 15 characters. And it yells at me. That's the reason we do this. Because if I got rid of this S, can you guess what's going to happen? Hopefully I can just do this. Actually, let me save this. And in case you wondered why asserts were useful. Here we go. And here we go. Yeah, I want to stop debugging. Hopefully it'll let me call that function. Damn it. Get to include CRT warnings. Ah. Okay. Oh my God, Google, you have to stop doing that. Okay. And I'm going to define C, underscore CRT secure no warnings. That should do it. All right, everything's working. Let's blow things up. How big do you want this? Second message, by world. We said it was going to blow up, right? We said there was too many characters. Why are you so cruel? Okay, way too many characters. Oh, it did give me an assertion. Damn it. Where is it? Ah, it's too big for that one. Okay, let's stop. Let's do it one more time. I just have to use by world. I got all cocky and started trying for other things, and it found it in the other function, the get s underscore s prevented me from going too big. Okay, how big do you want the array? 15 by world. Plus hello world is more than 15 characters. What the heck? I didn't think we should actually cause that error, or it just blows up in my face. String concatenation, print it off, freeing it. Is by world hello world? And it notice it clips it off. I'm surprised it actually gave me an assertion at all. That is really alarming because it allows you to do stupid things if you don't have the underscore s version of things. And this is why I suggest having those in there, because the stupid things you can do is just blow right by the end of your array and just merely stomp on memory in other places. It's not your memory to stomp on. You can just stomp on other people's memory. That's a big problem. That's why we have these things, to prevent things from like people passing in gigantic strings into your array, into a small little array, that sort of thing. So hopefully that makes sense. But if you're missing a parameter, you think you need the size, you may not need the size, you might be missing something. You're looking at trying to figure out what it says based off the little pop-up that you have there, or just do a quick Google search for the name of the function to see what you have. Okay. Can I unpack anything else? I got to go pick up my kids in a second, but at the same time, I'm more than happy to see what we have. Okay, can we go over the reading the text file in the program? Because mine won't, even though it's in the same resources file and directory. Are you sure it's the same file? So let's make a brand new, a new item. That's very annoying. That's in the way. Utility, text file, test.txt, good enough. Okay. So I have test.txt, and this is hello world. I can't come up with good examples, it seems. Why are they all the same? All right, great. I'm going to save that. I'm going to go to this thing here. So let's read in the array. So here's my dynamic text array. Let's do file. Okay, I have a file pointer. F open underscore s. It should take in a pointer to my file pointer. And the file name is text.txt, because very texty text. And the mode is reading it, right? If I'm writing it, it's a different beast altogether. But then I just fprintf. Wow. Why are so many people writing on Discord while I'm doing a lecture? That's awesome. Anyways, let's have a look at this thing. So what do I do? First of all, let's see if it opens. And then if p my file does not equal null, I'm going to start reading in my file. Oh, sweet God. All right. Next, I'm going to use fgets. Should be underscore s maybe. And no, it won't need that actually. And I'm going to put into a static text2 and the max count of this thing. I'm gonna make a giant static array and then my file stream. So p my file. And I really wish people would stop pinging me while I'm doing this lecture. Okay. Okay, a static text2. Anybody want to just yell at your fellow students for bugging the crap out of me during my lecture? I should have turned this off, but really, like, that's freaking out of hand. Okay. Thank you. Okay, I'm going to get in the first line. I'm going to say, let's say, I'm going to just get the first line, and then I'm going to close it. So f close, and then I have my file stream p my file. I'm just going to read one line and be done with it. And then I'm going to print off my line, print f, and put it on a new line. The first line. Okay, and I'm going to have a static text2. There you go. Notice I don't have to say how big the array is because I have a 0 at the end of my string to tell me where the end of my array is. That's why this thing actually works. Is it going to compile? Hey, it actually compiled. Let's see it in action. Notice I double check text.text, text.text. They have the same name. They are actually located in the same if I look at the properties, I should be able to look if I can move this thing around. I can see where it's located in my directory structure to make sure it's with the rest of my code. Right, that's what I want. It's in the same directory structure as my CPP files. I know where my CPP files are. They are in that same directory as test.text. Okay, so let's give this a roll. And okay, how big do you want my array? Let's make it 30. Who cares? First line of the hello world, I can't come up with. It should be good. All right, and everything else worked. It read in the file, pulled off the first line, and I closed it afterwards. By world. Okay. Hello world comes before by world. Concatenated string is hello world, hello, by world, hello world. It didn't actually blow. Oh, because I had made it size 30. There you go. Okay. If I look at my text file with good. Oh, with good examples, it seems. Plural. Great. Does that make sense? So we've read in a file as well with this. Here is the file name itself. It is in the same directory as where my CPP file is. That's what you needed. And you want to make sure that it works before you move on, right? So you want to make sure you have this in here just in case. fopen, unlike fopen underscore s, requires you to pass in a pointer to a pointer. Yes, you can do that. A pointer to a pointer because it's actually going to change this thing here. It's changing pmyfile. So if it opens correctly, pmyfile is going to change. If it doesn't open correctly, it doesn't change and it stays or it sets it to null. It's a little quirky in that respect, so I didn't want you guys to panic too much about it. I figured you would mostly copy the approximate format of how fopen works. Because in order to use fopen, you need to know what the heck a pointer is. This is a pointer to a file. Is that making some sense? Hopefully. All right, let's see what people are saying. Thanks. All right, no problem. All right, let's see how we're doing for time. 2:06. Okay, I think I actually do need to head out, guys. I'm hoping this clarifies things. When I come back. I'll be offline for a little while because I have to pick up my kids and deal with them, screaming, shouting, begging for video games. But when I finally get back to this again, thank you. When we get back to this, I'll try and make sure that I answer any questions you have before the deadline tonight. Okay? Perfect. Thanks, everyone. And I'll stop sharing my screen now. Have a great day, and just let me know if I can do anything to help. Okay? Thanks.